Hello, everybody. My name is Khawaja Shams. Welcome to the Cash It podcast. I'm super excited here to have one of my favorite people in the world, Alex DeBrie, on the podcast with us. Uh, Alex, would love to hear a little bit of an intro about yourself.
Yeah, sure. Khawaja, thanks for having me on. I'm excited to be here. I am an independent consultant, AWS Data Hero. I do a lot of work with DynamoDB and just like serverless architectures more generally. And then I would say broadly, just like and enjoy databases and learning what's new in that space.
You're a prolific author. You've authored the DynamoDB book that many of the people use as the authority on how to design using DynamoDB and how to make the best out of it. I'm a big fan. I have a signed copy of my own. Um, yeah, it's always fun to read what you have to write. But let's go back in time a little bit, if you don't mind. And I would
Sure.
love to understand, if you put yourself right before DynamoDB came out, walk me through what would excite you the most if you heard about DynamoDB for the first time today.
Yeah, that's interesting. So assuming the like current knowledge that I have, if I could export that back, because back in 2012 when Dynamo came out, I was actually in law school and I was not I didn't know much about databases at that point. So, but if I knew now what I knew and Dynamo was coming out, I think I would just be excited about what that core promise of Dynamo is, of just that consistent, predictable performance at any scale, which is something, my first 5 or 6 years programming, I didn't care about that so much. I think I would get excited by different features and bells and whistles and what you could do and the flexibility of that and things like that. But then, once you get some things into production and now you're dealing with outages or, alarms that are constantly going off or getting woken up in the middle of the night, things like that, you start to appreciate predictability and consistency and, fewer operations and just knowing what you're going to get no matter if you're in a dev test environment, if you're in production, if you're really hitting new scale, it's not going to change sort of how that stuff works. It's really just the other things that you need to keep thinking about and advancing that way. So understanding like, hey, that predictability is worth a lot more than flexibility in a lot of cases.
Right. But these features, this predictability at any scale comes with some limitations, right? Like I
Yeah.
can't run stored procedures on DynamoDB, or I can't run a particular partition hotter than I want it to be, or
Yeah.
as hot as I want it to be, and so forth.
Yep.
Are these benefits, are they worth these limitations?
I mean, it depends, right? It depends on how big your application is going to be and what your tolerance for pain is, and just like how well I think you understand some of that stuff. But I think so. Like I'm in the case where, I think the database or databases on the complete opposite end of the spectrum would be like Elasticsearch or maybe Mongo, which are really flexible in what they allow you to do and can do some quite amazing things, but just scale in completely unpredictable ways depending on how you're using those things and how that interacts with your actual production traffic. And it's just, man, it is that trade-off of just like, do I want to move a little faster at the beginning and not have to worry about some of that stuff? But now I'm in a situation where it's continually melting down and it's hard to find a way out of this stuff. There's like something that sort of forces me down the more scalable, performant, predictable way from the beginning.
Got it. I'm a big fan of Dynamo as well,
Yeah.
and I really appreciate the predictability at any scale as well. But if you fast forward to today, there's a new type of database that is being talked about a lot more, at least more recently, and that's vector databases. And I'm curious to hear your take on the current state of vector databases from the perspective of somebody who's been working with databases for a while, and just curious if they are closer to RDS or DynamoDB today.
I think they're closer to, I would say, I would consider them closer to like early stage NoSQL based on what I can tell. And just that, hey, it's an interesting new pattern. It can work for some things. And if you put in the time or the thinking to use them correctly, you can get some good mileage out of them. You can also just start throwing data in them and showing off cool demos and figuring out that doesn't work very well. It's scaling up wise. So I think the hard part is sort of separating fact from fiction in just terms of like what it can actually do and where it can work, and not knowing just like what are the sort of on the label capabilities. Like, hey, you can query these vectors and do nearest neighbor search or different types of queries like that. But actually understanding like, okay, is this something where I can do lots of more OLTP like adjustments to my vectors while still getting good query performance? Or is it something where I want to, you know, load my vectors in advance? Maybe they're not changing very much. Load out, like make sure all that indexing can happen. And now I can get like more low latency predictable queries, but sort of like updates aren't going to happen very quickly. Right. And for me right now, it's just hard to understand where we're at. Like just this morning, I was looking at Eric Bernhardson, I think is his name. He used to work at Spotify and made like Annoy, which is a Python approximate nearest neighbor library. I built the Spotify and a few other things. And he's got some benchmarks for like nearest neighbor searching for libraries and also for databases, Milvus, Elasticsearch, PG Vector, things like that. And I still think we're just like so early days in understanding like where those trade-offs are going to be. You know, I don't think we're anywhere near the Dynamo phase yet, just because vector search is a different type of problem than sort of partitioned key value type stuff or key value, white column, whatever you want to call it. It's not as sort of like easy, clear of a scaling problem than that. So we're not in that space. So given that, now you really need to know a little bit about your workload and how to like what trade-offs you're going to make. Am I going to give up individual updates, or am I going to give up massive scale and or low latency queries and things like that? So I think we're still discovering that, and I'm not sure, just like the collective community knowledge is there yet.
I think part of that is just it's early days, right? It's
So early, yeah,
and the industry is just moving a mile a second kind of thing, right? Like
yeah,
there's new vector databases coming out. There's a lot of work going on. There's a lot of usage showing up. And so I can't wait to see what it looks like in a few years from now.
yeah, yeah. The hard thing too is like it's land grab right now. Like there are these new databases coming out, some funded, some open source, and maybe looking for funding, and then there is sort of like, I think from a product perspective, there's just the answer is yes, right? Like we'll do everything. We'll add every sort of capability to get as much usage as we can. And that can lead to like a bloated, less focused product where I sort of wish there were more like clear lanes in the vector databases. Like this one is good for this sort of use case. Hey, if you have data that's not going to be changing a lot, but you have a lot of it, you can just upload that, make sure it's indexed super well for all your use cases, and then like low latency queries. But if you're like, hey, we have a smaller amount of data, but it is changing quite frequently, this is a better one for you. Just like we have flavors of those other ones, it doesn't seem like the vector stuff is going to be one size fits all, even though, the databases are playing that way for now.
I think some of those partitions will, no pun intended, will emerge over time, right?
Yeah.
These databases will find their niches over time. Why is there a land grab?
I mean, it's just like, it's any kind of new space where they're trying to get the users. Like it's hard to build momentum for a new database where you need especially a new type of database. Sometimes you need to teach new query syntax. Some of them are using SQL-like stuff, so it's not that different. But even just like teaching, a lot of people didn't know what vectors were 6 or 8 months ago. Like, I barely knew that. So understanding what that is and then how you use it, like it is just you need to build some momentum. And I think momentum breeds its own momentum in especially the database space, because then you get more people writing and talking about how to use this one. Other people use that for demos. So it is just like so much of a land grab in terms of trying to get that developer attention. And then maybe to do that, you get people that are like, hey, I want to use it for this use case, but I'm missing feature X. Can you get that in there? And they say, yeah, we can do that, just to keep blowing that up, even though that's maybe not the right long-term outlook for the project. So like, going back to Dynamo, that's one thing I love about it is like they have had this guiding vision at all times of like, hey, it's going to be consistent, predictable performance at any scale. And any feature that sort of would violate that is just a hard no. It's not gonna get in there. It's not gonna be like, hey, we can give our customer or our users some nuance here about this won't scale as well like some other databases. No, it's just like, hey, that's a hard no. We're not gonna do.
But I think I really do agree with that. I love that. I think you're talking about why an individual vector database might try to cover it all.
Yeah.
But I have never seen anything like it where so many new, database trends come over all the time, right? There's like HTAP came, and then there was
Right.
maybe 4 or 5 new companies that emerged doing HTAP. But on the vector side, it's kind of insane, right? The
Yeah.
number of companies that are popping up doing vector databases. So I was curious if you have any commentary on why is this suddenly so popular? Why does
Uh,
everyone want to build one, and why does each one of them want to cover all of the dimensions?
yeah. I mean, everybody wants to build them because, the chat GPT and just general GPT hype, like we've seen the possibilities from that. And I think chat GPT particularly showed just, wow, there are like a lot of capabilities, which is kind of weird because I mean, basically GPT was kind of hiding in plain sight for a couple of years because, it's a slightly better model in the original chat GPT, but not that much better than GPT-3, which was like basically available since 2020. So I think now they're just like, oh my goodness, there are so many capabilities. And because of that, a lot of people want to put it in their products in all these different ways. And also because of that, your GPT models, they have this knowledge cutoff, so they're missing stuff, or maybe you want to, just improve the context for your particular domain. And so now you need to be collecting examples that are similar. So now you need a vector database to do similarity search for better text generation, or maybe you're just doing similarity search, in the vector database directly, not even going to GPT other than to generate those embeddings, So I think just the whole LLM hype and the capabilities that were displayed with ChatGPT is just getting everyone's, mind going about that stuff. And now it's like, hey, we need some sort of database that can actually query these embeddings well and take advantage of these new capabilities.
And I think time will tell how much of it is hype versus the
Yeah.
actual new capability. I do agree with you that there's a lot of hype, but then there's this balance because the upside on the capabilities is pretty nice. One advantage of Dynamo that I think goes understated often is that it's the pace of iteration, right? Like once you learn to work under those constraints, you can get stuff out really, really quickly. If you need to open a store or do registrations or whatever, and you need to hit millions of TPS, you can just get that out in an afternoon, and it scales without having a PhD in distributed systems, right?
Yeah.
That was the fundamental premise of DynamoDB.
Yeah.
And right now, to me at least, the vector databases, they do require a lot of know-how because the industry is new and they are trying to do a lot. Um, but you talked about the various, dimension and specializations that these databases could take. I'm curious for the databases that you're playing with and the use cases that you're coming across. Do you see this as more of an OLTP type workloads or OLAP type workloads for the vector databases?
That's a good question, and I don't know enough for sure, but it sounds like based on discussions I've had, with you and with others, is like it sort of depends a little bit on your data shape and velocity, like volume and velocity, all those things that we talked about for a while. Like, if you have a much larger corpus, right, but it's not changing very often, I mean, then it might be more of that OLAP-y shape where it's like, hey, we can build a pretty good index for this that works really well and gives us really good queries. But if you have data that is changing more frequently, well, now you need those OLAP like things to be updating the vectors, or maybe at least like the metadata around the vectors. And it's harder to keep that index updated as compared to like a normal like B plus tree, in a database. So then it just is like either you're going to be using sort of less efficient indexing methods than you could if you had more like an offline or OLAP process, or you're just going to have less data or fewer queries that you can do against it. So I think it still depends. My guess is you'll see sort of lanes emerge just because I think you'll have different use cases. Some people will have a ton of data that they just want to be able to search through pretty quickly, but it's not going to be changing that often. And some people are going to want to have hotter, more changing data. And I think we'll see both of those emerge. I don't have a good sense of like which one, the space is even better at right now. I think most people are playing around with small enough bits of data, Slack chat rooms, some Google Docs that they're ingesting for the company and playing around, where we're still talking about pretty small amounts of data, GitHub repos, things like that. Pretty small amounts of data. You might not even need a vector database. Maybe you could do that locally for a lot of those things. But it's going to be interesting once we get into, if you have lots and lots of data, lots of embeddings and vectors that you need to fix there.
Yeah, I mean, I think concrete examples are like knowledge bases. They're not changing that often. You might have a ton of data, but pretty static for the most part. But then you've got things like real-time orderings, like let's say if you're building DoorDash or Uber Eats, or you're trying to provide real-time, search on real-time data. And
Yeah.
that's when things can get a little more churny. So I
Yeah.
think it's a profound point that you're making, that as the field matures, these lanes will kind of emerge. What in this land grab mode that all the vector databases are at, what do you think is missing today?
Oh, I mean, usually honesty, right? Like everyone wants to say that they're good at everything, and I wish people were just a little bit more honest about like, hey, these are the use cases we're really good at, and sort of nail that. But I think people don't want to limit themselves too early or pigeonhole themselves and figure like more adoption is better, and we can figure out the other stuff later. In terms of what else is missing, I just think really it's community knowledge and documentation and understanding of like, hey, here are like the dimensions on which these things scale and what you're going to need to think about, and if you have terabytes of data, like if you're talking about knowledge bases, or like, yeah, I used to be a lawyer. We use like LexisNexis, like think of like all the court cases from all the state courts and federal courts from all sorts of history and things like that. Not changing super often, but it's a ton of data, right? So it's just like a different type of problem there. And just understanding like, hey, if I have that much data, what is that going to look like in terms of scaling? How am I going to, be able to filter and query that well versus other things? How should I organize my data? Even like, hey, if I have a big document, should I create a vector and embedding of the entire document, or should I chunk that up into different chunks? And how do I chunk that so that it's giving me accuracy without losing the context of, the surrounding document, because the document is in conversation with itself at different parts and things like that. So I think there's just like a lot of work to be done there, especially if you're looking at that like retrieval augmented generation type stuff. Like there's a lot of work to be done there, and figure out how to use this stuff well, how to prepare it for your database, how to query it from your database, and think about operations and scaling. It's gonna be a journey,
I love this. I think this is profound. What you're saying is there's a lot of material you see about how vector databases work, what is a vector and so forth, but you want the educational material to go beyond the basics and more towards how do I operationalize this? How do I put this in production? And I agree with you. I don't see a lot of that. I see a lot of how to rapidly, put a prototype up there and
Really.
maybe some explanation of how it works. But the real world trade-offs that, and this is what you practice, right? Like you use Dynamo as a tool, but you help people get to production really, really quickly and operationalize their stuff using DynamoDB. And as the industry matures, I would imagine as more people like the experiments that they have built, these are inevitable kind of
Yeah.
questions that might be getting overlooked in the land grab moment
Yeah. Yep.
all these
Honestly,
people.
like just to give one example, like a lot of people are turning to PG Vector, right? Which is an extension for Postgres to add like vector indexing to that, so you can index these vectors. And I know like early on, the number of dimensions they could support in that vector was fewer than the dimensions you get back from a OpenAI GPT embedding, which is like, the most popular AI. So then it says on there like, hey, if you have vectors of more dimensions in the PG vector documentation, it says you need to figure out some way to reduce it. How do I reduce it? Like, do I just chop off the last like third of them? Like, is there some way to condense that down? Like, what are the trade-offs there in terms of that stuff? Like, and if that's true, if I'm using OpenAI or one of the GPT models, like, should I not be using PG vector? Should I be using something else? And just like understanding the knobs there, like we just don't have the capabilities. And I think we're just winging it in a lot of places. And it's like, we need to understand how that's happening. And I think that's like that's more true in NoSQL. That's true in like SQL. We're understanding how those things scale and things work. I don't think we have any idea on vector databases yet.
Right. And performing at scale and so
Yeah.
I totally agree with you. The limit of 2000 dimensions on PG vector took me by surprise as well. I am really happy though that people are putting these things together, right? Because that's
Yeah.
how innovation happens. So now we see support inside of OpenSearch. We see support inside of Mongo.
There
We
you
see
go.
support
Yep.
inside of Postgres. And then there's purpose-built vector databases with lots and lots of vector-specific knobs like Pinecone, EV8, and so forth. So there's lots of innovation happening. I think it's because there's potential here,
Yep.
and the industry
Yep.
kind of figuring it out. And you made this other point that I really like, that in many cases your vector database may not even need to scale, right? Are there applications where you see like there just aren't that many vectors and it doesn't matter if you have a hyperscaled vector database?
Yeah, I mean, a lot of people have a knowledge base that's not that large, or even just like company documentation, right? You're the founder of Memento. Indexing all the Memento documentation would not be that much data. But then being able to do like similarity search on that and trying to figure out the right page at least to go to, and maybe the right section within that page, you could do that, and that's something that could run. I mean, you could probably package that. You could run that index, packaged up in a file, and put that in your Lambda or your web, whatever's running your web server, and it could just run it locally without even reaching out to any type of database at all, right? Just because there's just not that much data there that you're talking about. So, um, I think that's the case where sometimes local is good enough. I'm working on a project where we do some indexing of like GitHub repos or Google Docs locally, pull those down, run that indexing locally, and then just destroy it because it's just like, hey, we don't have the need for a full-fledged vector database in that case.
Got it. I really like the serverless model for that because it actually scales down to zero. Like storing my picture, if I want to just share my picture with a friend and if I dump that into S3 for like a 1 MB object, I don't need the massive scale that S3 provides, but I can still do it. It's super easy.
Yep.
And if that turns into me wanting to build an entire smug mug and, store millions of photos on it, it just kind of works. But I'm only paying for what I'm using. So I kind of like that aspect of the serverless revolution as well.
Yep. Absolutely. Yeah. It works for tinkering, and it works for, taking your tinkering to the next level as well, which is great.
That's right. Um, all right. Now I have a confession to make before we end this podcast. And I want to know if you will disown me for making this confession.
Oh
So,
no. Yeah.
so Memento uses DynamoDB behind the scenes for its
Yep.
scheduling. And I have to admit, there's more than one table. Is that okay?
Yes, that's fine. That's something it's been an interesting journey over the last couple of years on that. I definitely came in like kind of guns blazing for single table once I learned it, and I still like single table for a lot of things. But I think there are reasons like, and you and I have chatted about this. Pete Naylor is really great on this. I'm just like, hey, make sure you're being rational about how many tables you're using, and if you're not getting the benefits. I think just like understand the benefits of single table and make sure you're getting some of those. And if you're not getting those, like, hey, feel free to have multiple tables. And I think especially with like, some of the like on-demand pricing and stuff like that, it used to be like, I don't want to just maintain the provision capacity for 20 different tables and the alarms and all that stuff for 20 different tables. But hey, if it's on-demand pricing, like now you don't even need to think about that at all. So it's not that big of a burden. So, yeah, no, there's no shame. I won't disown you for not using single table.
All right. No, I always learn a lot from you, Alex. I think what you're saying is single table can be great, but sometimes it's okay to not always be use that as the answer.
Yep. And I really like it as a learning tool. Anymore, like the more I think about it, it's a good learning tool because so many people sort of conflate the like the schema and just like the index, like being able to index anything on their relational database and just the flexibility, query anything there. And really, if you look at it, most of you like not thinking about access patterns as much. Whereas if you think about Dynamo or things like that, it's just like, hey, you need to think about like the 2 or 3 ways you need to access your data, and then everything else is just like a blob that you can use in your application. But it's really those like identifiers for your data, and that's going to give you then the partitioning, the horizontal scalability, and consistent performance, and all of that stuff. And if you think about that and understand that, I think that's most apparent with single table design because you're realizing like, hey, it's really just those keys I'm accessing stuff by, whatever they happen to be. And then if you want to go away from single table, I'm fine. Just like take those that knowledge of just like, hey, it's how I'm accessing the data and the rest happens in my application. I think that's a useful point, whether you're using Dynamo or Postgres or whatever.
Nice. Alex DeBrie, thank you so much for being here. Super excited to see you next week at MoCon. And yeah, always a pleasure to learn from you.
Likewise, Khawaja, thanks for having me on. I'm excited to see y'all next week as well.